I would like to get through with you to some aspects which were very well introduced from my perspective to the talk before, because in the end we had this this recommendation, work into business models. I think it's very important that we think in terms of business models and business strategies aside from thinking in technologies. We need to do this as well. So since I'm from the logistics side, I'm not a specialist in informatics. My talk will be more on the side of business and framework and lessons learned. So what I want to do is, after I give you a brief introduction into our university and where it is, I want to show where we come from in terms of Internet of Things, because there is no future without past. And we need to understand the past to avoid making mistakes which we might have done in the past. And my experience goes very far into the past. As you heard, in 1998 I did the first study on passive RFID in the consumer supply chain. So I served a lot of hype cycles in this field, and I just want to share some ideas on lessons learned with you to discuss what has changed and what can we do in the future. And as one, so to say, a little insight from Germany, what we do in Germany in the field of the Internet of the future, I will give you a slight insight into the Industry 4.0 approach, which is more or less a German approach, and as well a little case on the secure farmers logistics, where we are involved and drive projects in this field. Okay, first of all, I do not need to show Berlin in relation to EGA. Kassel has to do it, but Berlin, I think everyone knows where Berlin is in Germany. It's more important to show where is the University of Wildau. It is more or less in Berlin, and it's part of the scientific community of Berlin, which is a very, very strong community, the strongest cluster we have in Germany with universities and research organizations. So that's our position there, a very, very nice location. You are all invited to visit us. We have a lot of students from abroad, and when you see our key facts here, 4,500 students, just to give you an idea how big we are, 90 colleagues, or 89, 25 programs, and we are most of the time, year by year, the strongest research group or university in the field of universities of applied science, with 10 million funding, not directly from the government, but coming from the industry, coming from research programs. We are very proud of it. If Laszlo Ungvári, our president, were here, he would give you more statistics on that, because he's professor for statistics, and he knows how to present statistics. You understand what I mean? I have the chance here to do research as well. I come from the logistics, as we heard already, and our field, so I have 6 research scientists in my team. So our competence field is what we call logistics-focused security research, because security becomes more and more vital for everything. Not only for cyber issues, but also for processes in the logistics, looking into the weather changes and so on. We have big issues with security. And we are in a program where we do research in this field. And as you can see on the left side, it's very much also based on technology. but not so much to develop the technologies, but very much to understand them, to assess them, to evaluate them, to bring it into innovation in respect of the processes. And as you can see on the right side, which is very important, and we have to address this all the time when we look into new internet approaches, it's the markets. First of all, the markets, because the markets gives the money to everything, and on the other hand, the society. And we made a lot of mistakes in the past using technologies without looking into the feelings of the society, to understand the society. Technology approaches, techies very, very enthusiastic about the technology, brought something in which on the other hand gave a lot of acceptance problems. So we do research also on the acceptance. We are in an interdisciplinary field of research with social scientists and so on. So I think that's very important, and in the end, in terms of the business model developments. Okay, that's just on us. To give you a glance, we have a lot of large partners which you might know from the logos. So we are quite successful as accepted research partner in this field. Where do we come from? Why do we want to use the Internet of Things, or why do we do our business because of the Internet of Things? We had heard about it. It is all about miniaturization. It's all about digital convergence. Bring in all the platforms to one device. I mean, the smartphone is the best to understand convergence device. We can see it's machine to machine, it's ubiquitous computing. And this enables everything we need to do today, like globalization, real-time enterprise, not so much thinking about locations where we do something in the world, and very specially mass customization, or lot one, meaning the individualization of the customer leads to a pressure to build to the needs of the customer in terms of build to order rather than build to stock, which this was the former way we did it. So we have now the requirements to get a pull supply chain out coming from the customer's needs. And everything we heard about, also including the customer, helps us in this way. And smartphone, again, is a very nice, easy to understand communication channel to bring the needs of the customer directly into the production line. And we see it afterwards. That's about Industry 4.0, what we understand it like. So this requires it, and it enables it. So we have a acceleration here in doing processes and businesses by using those technologies. But very, very importantly, please don't forget it, always to talk about it. We had it on the slides. Standardization is key. Standardization in all these processes and technologies has to be fostered and driven. And we need to understand, and that's why I like to be here in an EU context, we need to come up with our standards from Europe and not only taking them from elsewhere in the world, which a lot of times happened in the field of internet. We all know where the internet is hosted, basically. So thinking about own infrastructures is the greatest thing we can do, and we need to be strong in that via standardization. But we also have to governance it to get the legitimation in the fields of acceptance. Privacy is key. Okay, Germany, again, is world champion of privacy discussions. But it makes sense to cover this privacy issue. And the communication, how do we communicate to the customers, to the business, to the society, our approaches. And in the end, because of the demand of flexibility and agility in the field of the processes, we need to come up with good approaches and innovation which are accepted by the market and can be implemented. That was the idea when we started long time ago, around 1999, up to 2003. That was the mega development time frame for RFID, and to overcome the media break was the real driver there, and this was the key driver. But in the end, when you look to this slide, the overall vision in 2004, this slide is from 2004, was to, on the one hand, understand human-machine, efficient, secure communication channel for access and buildings to building services and content, what we heard today as well. And on the other hand, the machine-machine communication like intelligent objects too. And this was the idea this year, 10 years ago, to have the smart fridge, when you remember this. Okay, so same ideas, but different bases, hopefully. And how did it started really then in the implementation? We have to see RFID was very much a competence of Europe companies and researchers. So the technology was very much on the European side with the HF. Something wrong? No. The HF development 13.56 megahertz. And in 1999, there was an understanding in the USA that RFID will be a very important part for the economics. And then that's the difference to Europe and the difference to Germany as well, as a part of Europe. Then they got an alliance together. So large companies like Walmart and Gillert and Procter & Gamble from the US side and then from Europe, they gave millions of US dollars to push the concept forward. And the one on the right side with this, the bird there, that's the Department of Defense. So the Department of Defense, the largest supply chain in the world, supported this idea. So that's very strong. And then you look in the ecosystem which was built there, and they started then to create the Internet of Things based on the EPC approach at the Auto ID Center between 1999 and 2003. And all the patents and all the IP or the main parts of the IP are in the US, not in Europe. The standards are driven by the US. And from the Auto ID labs, we had then this development into GS1. So it was in 2003, it was implemented into the GS1, the Global Standard 1 organization, to push the standard forward into the implementation. And one of the biggest, let's say, restrictions in getting the success we thought we have by billion and billion of tax was that, again, the infrastructure was set up like the Internet. So the Internet of Things in this approach is like the Internet, that we have with every product in the world one URL, one homepage, so to say, and we need a kind of domain name service, which was called is called the object name service. And that one was meant to be hosted in the US. And then a lot of governments, Germany as well, Europe, said, no, we don't want you to host the whole infrastructure on our supply chain. I mean that, yeah, they control our supply chain by hosting the ONS. And that's just one example why we were not that successful as were predicted. So we should have, in 2007, we should have had a billion of tags all over the supply chain, the retail supply chain. That's not the case. Slowly we get better in the fashion industry, but we still are on the pallet level. Yeah? It's not that developed. So there are a lot of obstacles which we can use to learn for the future. And when you look into the Gartner's hype cycle, everyone is aware of the Gartner's hype cycle. It's very, very interesting to read this every year on technology development and assessment, how they move forward. So the idea is you have for a technology trigger, someone gives the idea, there is a possibility, for example, the quantum computing, and then it starts to be discussed on conferences like this. And it's getting more and more into the press and media. And that's the hype. And then it reaches the hype point, the peak of inflated expectations. So that was with RFID. That's the world saver technology. We will move forward in all the processes and so on. And then with most of the technologies, you get this problem that it drops from the peak into the so-called throw of disillusionment. So everyone is frustrated that it doesn't work like it should work. And when you see here, RFID is in 2006 on the way into this field. And I would say today we recover slowly from that, depressed and frustrated. And what we can see here, the smartphone is on the way to get into the business arena. And the smartphone is something which gives a lot of change to the discussion. When you look into the Internet of Things or the future Internet you presented, a lot is around content and people, Internet of People. So there's a change in the whole seeing or understanding of the thing. And the smartphone has changed a lot in terms of RFID. So we have seen that, but here again, that's the smartphone that's as a trigger. It's on social networks, it's on content, it's very much on people, and it has to come together. But this was all set today already, so I cannot give so much to it. The other thing, just before I forget, the other reason why it wasn't that successful the years was it was demanded by the retail. Most of the logistics application, and I talk only on the logistics application here. Yeah, we have a lot of smart cards, we have a lot of niche applications, but in the logistics, in the killer application of RFID, it was demanded by the retail. That means it was not a full economic approach, because the value creation was not throughout the whole supply chain, it was just at the point of the retail. And that's one reason why it is not that successful. Overall, it's not functioning 100%, it's the other thing. Okay, so we are now in a different arena. And again, I give you here a cloud of terminology. We have to be aware of that. We create more PowerPoint slides and terms than real application and concepts. And we need to understand what is the right phrase to put it in the right way. In that direction, what you can see here is all relatively close together, but you have a lot of names for the same thing. So we have to come to definitions here. So Industry 4.0, and it's written in German because it's a German idea, is something like cyber-physical production systems. And I'm a little bit scared that by using an own term for that, as Germany governmentally pushed, that there is a risk that we lose the standardization road, so to say. So it's always a little bit tricky. But what the thing is here, we come now from the problem RFID was mandated by the retail to the point where the manufacturers see a lot of useful applications and value creation by using the Internet of Things, using RFID, but using all the other things as well. So now we become a different economic system, what was not in the place when we started with the EPC approach 10 years ago. So what does it mean? The idea behind the Industry 4.0 is the supply pull. So what we have here is the idea, the smart factory is a combination of physical and human networks. Again, we saw the slides before, the world come together. We have smart devices, we have smart products which communicates with smart machines and decide together what is the best step next. That's the idea. We need to extract and storage the data. We need to come in with the big data approaches. Again, it's all the same. It's a different name, but we talk about the same. So we need the big data analysis, algorithms and data analysis, and we need very much other data sources. And again, here we come from the customer side, who is able to give through social networks, through the direct connectivity, being part of the network of the producers and manufacturers, using the smartphone, whatever, gives direct introduction of requirements in this whole course of manufacturing. And this is all comes together to smart data. And then it goes into the production process by getting into production planning programs. So understanding what would be, in terms of predicting, with very high accuracy, predict what a customer will order next, we come to a kind of build-to-order situation. Very, very fast, very, very flexible, and we can go into the lot one or the mass customization easier as we can today. And so we get into the optimization product and processes, and then we start again. And also here the cloud-based networks are very important to support this. And I think René will give more insight, because he's also from Wildau and will give a talk tomorrow, and a little bit more technical on how it's done using sensors in the production. It's not a topic of my talk here. So that's the idea. You have the information from the big data, from the social networks, what is needed, and the manufacturer can easily change the programs towards the next requirements and demands. That's the idea of being flexible and agile in the manufacturing world. And that's very important for Germany and for Europe, but especially for Germany when you think about the economy, how it's structured. Our biggest industry is the machinery industry, building machines for production. We are world champion in export of those machines, but we suffer from losing the differentiators, because other countries can also build machines. We learned it from the car industry. We have very good cars now from all over the world, still good cars from Germany, but other countries can do the same. So what is the next innovation step? And we have also, on the other hand, a large internet or in IT industry. Both together are the both most important economic factors in Germany. And now there is a convergence between machine and IT. And it's on the economic side, it's the convergence between the industry of machines and the IT in Germany. And that's why it's very important for the government to say we need to be at the edge of the developments in Europe, together with Europe, to set the standards of the future. Otherwise, we will lose our machine industry, the production industry, basically. So that's the idea, and that's why on the IT summit 2 weeks ago in Hamburg, 550 million were given to this approach of Industry 4.0. It is all implemented in the discussion in the ICT directories in the EU. All this standardization has to be done in the EU, but it should be done from the EU to export into the rest of the world, so that we build a European infrastructure more and more and get a little bit more independent from the infrastructure we have all on our smartphones and all on our PCs, which is basically located in the US. And we have the Googles and so on, they are not in Europe. So it's on not only on technology, innovation, it's also on economic aspects. So what we need to do to converge those two worlds is to come from the physical objects, devices, you know that. We have to integrate them into embedded systems. And that's the point here why RFID will change completely. We will see still simple, stupid RFID tags, but the value creation we will see in more sophisticated, as you gave in your presentation, with some localization, with some temperature measurement and so on. That's the value creation. And still the simple RFID tags, they are even not much fun for the semiconductor industry, and I was with a semiconductor manufacturer, I know what I say. You cannot earn money from it. So sophisticated embedded systems. And it's then maybe not, we shouldn't call it then RFID, we should call it RFC as a radio frequency communicator, or we should call it RFA for radio frequency authentication. And on top RFID, yes, but since we use RFID as the all-over global approach, we don't understand really the differences and the applications. We have to think in applications rather than in RFID. Embedded systems are in the place, will grow. And then we come into the data is one, information is more. And we have to make from the data the information, and that's not without semantics. So we have to understand the processes, the world, the roles, everything which is connected to that. So semantic description, then of course the connectivity, and then we have the cyber-physical systems, and are part of the Internet of Things using our very new IPv6. Now we have enough addresses for the rest of our human lives. That's what we thought was IP4 before as well. But we can really address a lot of objects in the world. And on the other hand, we have the development in the world of the use of the virtual world. We come from the mainframe into data warehouses, but still on the PC level, we now get into, so to say, the cloud world where we are a user and have access to not only IP addresses, but really to databases in the cloud, to a lot of computers, smart devices, and so on. And that's the Internet of Data and Services. And that comes together. And I repeat only what we heard before, but that's what it is, and it shows us a little bit that we are on the same track. I mean, that's a positive aspect. But what should we have learned from the RFID history here? Our Association for our Machinery Industry, the VDMA, made a study. We suffer, and that's the same with the RFID, we have had a huge security problem. We haven't seen that, which was on the data privacy side. We underestimated that, and we recover slowly. We have now a privacy impact assessment by the EU, created to rule a little bit the applications in the RFID, with a lot of restriction for the market. It was because of the mistakes we did before. And now we look into let's say, cyber physical systems or Industry 4.0, and we face a lot of security issues. And when you look into the perception by the industry, you see that the incidents will increase in the opinion of 63% of the companies, cyber attacks and stuff like this. Already 29% of companies has been suffering from breakdown in production due to such security issues. Our Bundesamt for Security in the Information, BSI, has a cyber security alliance, and 61% even do not know of the companies that exist. Only 57% of companies know one of the common security standards, and less than a third has standards implemented. And that's critical, because what you can see also is the cyber physical systems, which have to be cheap, they are developed not as we had it before. Industry development pushes consumer development. It's the other way around. Consumer electronics pushes the development of cyber physical systems in the manufacturing. And if you look into the security platforms of our consumer electronics, and you put it into the industry automation process, you get all these weaknesses all of a sudden into this arena. And bring your own device is only one aspect in this respect as well. Yeah. So we have 5 top threats in the machine industry, and if you see, 3 of them are related to IT, infusion of viruses into machines, online attacks, online attacks through office enterprise nets, which is bring your own device, and unauthorized access to resources. Okay, so 1 German for you. Okay, that's what we see and what we have to learn from to avoid those things. And we have, as a community, as scientists, we have to discuss this as well. Not only saying, I have a smart idea and I'm euphoric about it. We need to have security by design. We need to have acceptance by design. Everything which was restrictive in the past has to be part of the design. And you as a community of researchers have to think about it and discuss with other parties, actors in this community. That's my wish that we come to this point. Okay, to give you one little case, what we've been doing in this respect, again, a little bit German, it's the pharma distribution chain. And when you look into the regulations we have since 2013, the so-called good distribution practices. It's a regulation which forces the pharma industry, medical industry, to document, to keep rules, temperature guidelines, and so on, all over the supply chain. That's a hard pressure to the processes, because when you look into a supply chain, you have in the beginning you have the manufacturer of the medicines. They keep track on good manufacturing practices, and then you get into the supply chain, into transport systems, and now you get service providers working into this. So there's a lorry driver who is involved, who is not from the pharmaceutical industry, but he has to keep all the regulations and documentations. And the same with Industry 4.0, we need to make it easier for the people. So we need assistance systems, which helps them to keep track on all those regulations. And that's what we try to do, especially in terms of the cool chain, so the more storage and transport arena. And what we do there is, and that's simply a breakdown from what we know into an application. We try to create a box which is a kind of plastic material which keeps the temperature as it is, but then it will get a real-time location system. It will get an authentication reading system inside to read or to authenticate the medicals inside the box. It will have normal possibilities of GPRS communication and a temp sensor to keep to track the temperature inside the box. And we also look into maybe to have actuators which try to, or which allows to regulate the temperature inside the box. So what you see here on the display is then everything you need. You need an ID. That's something you can have from RFID in the simple way. But you need a location inside the warehouse. Where is the box? You need the temperature inside the box. You need the temperature outside the box. You need the place where to put the box, for example, and who's doing that. And this has to be given to the employees as information and with some action plans. And then you can come up with nice headsets for, which were on your slide, a kind of Google thing to visualize to the people, to give assistance systems. It's not to automate. I think we are far away from trying to automate everything and getting the people out. We are more and more on the way to get a new relation between the automated processes and the people. And we should fight for it, at least that we keep it. Yeah? And that's what we try to do in the supply chain, in the pharma situation. And there is a real pressure now to do something because of the new guidelines. It's sometimes helpful. And actually, they earn a lot of money in the pharma industry. They should give a little bit to us as a community of researchers. Thank you very much.